And now we have Kevin Berry and Eduardo Pineda who are going to talk to us about the economic impact analysis of space elevators.
Uh, and I think that I'll get to these bullets in a second, but I think this clip, Eduardo and I have found to be very poignant for our conversations today. That little video, I think, is going to express what we really want to cover today, is the quote, "We don't care how much it costs, we care how much it makes." And one of the pieces that we've been really honing in on is that so much of the talk since Bradley Atwood's paper in 2003, 2006, when he published it, has focused on different parts of the space. Or you have the tether. We've had lots of advancements in the last 17 years on that, which Mr. Nixon will be talking about in a little bit here. We've had transition from power beaming over to using solar panels to elevate the climbers. Lots of discussions have changed, but one of the things that has remained relatively stagnant is this notion that cost per kilogram in the economics of the space elevator is about getting things into space and how it can be cheaper than it is on rockets. And we would really like to shift that paradigm to focusing on how a space elevator is much more about value generation as an infrastructure project, as Dr. Swan alluded to earlier. Mr. Fines. And one of the important concepts to understand about this is the distinguishing point between cost and price. That the interstate highway system and the highways all over the United States are having a price of zero. It doesn't mean they're free. It doesn't mean that the cost of construction is cheap. Honestly, they're very expensive to build, but the price is driven down to zero. Whereas something like a Coca-Cola fountain machine here, the cost of the simple syrup and water is almost zero, and yet the price is very much higher. And this is a key difference between an enterprise and a infrastructure project, that while both of them are aspiring to reduce cost as much as possible, a business is motivated to raise the price as high as the market will bear, where infrastructure will take and reduce the price as much as possible, including below the cost, and subsidize it with the overall macro effects it's having on economic productivity, because they can subsidize that effort and increase productivity further by reducing price even more. And that this relationship holds true across many industries, that a linear reduction in price, even with noise, causes an exponential increase in utilization. And this is in large part due to the compounding effects of the network effect, as shown here on the right. That as you have a linear increase in the number of nodes in a system, you have an exponential, or in this case, geometric increase in the number of connections between those nodes. And the connections aren't necessarily physical. They represent the number of opportunities available to the network. And that as this number grows, your effective cost of using any single one of these lines drops and drops and drops to the point that it's a negligible sum, and you just have free flow of ideas and information throughout the network. This can be observed in what we've seen in aviation during the 20th century, that in 1940s, the cost of a ticket was about $4,600, and by 2015, it was below $500 for that same trip. And the convenience too went from a 15-hour trip to go from Boston to Los Angeles down to a 6-hour trip. And this tenfold reduction in price, let alone the having 12 stops versus 0 stops convenience factor, has caused an 8,000-fold increase in the amount of utilization in aviation. And this sort of exponential effect is far more than you would expect from just a linear decrease in the price. And what we're seeing in space today is that we're going through a crazy decrease in the cost of getting to space. In just the last 15 years, we've seen the price come down 4 orders of magnitude. And this Starship is still aspirational at this point, but if it delivers at $100 per kilogram instead of 10, the story remains the same. They are they have fundamentally changed what is happening. And we've seen response from the venture capital markets in this exponential growth and utilization of space is starting to become much, much more valuable and utilized because the cost of entry has dropped so precipitously. And part of the paradigm that we're trying to change is the space elevators. Right now, consumers have a choice terrestrially. If you wanted to travel between, let's say, Boston and Los Angeles, like in our previous example, flying is the most expensive option usually, but it's also the fastest. You could take a car and you could get there for cheaper and you would have a lot of freedom. Or you could take a bus, which is cheapest of all, but you have no freedom and you have to live with being on a bus. And this consumer choice is a logical, sensible thing where you're taking and weighing both the cost and the cost of the opportunities you're giving up by the mode you're choosing. And the dual space architecture is represented as this consumer choice. Do I want to use the space elevator or the rockets? They each have their advantages and disadvantages. And ultimately, we're doing like that. But as ISEC and the world tries to think about constructing a space elevator, this is a false dichotomy for the development of a space elevator. This is a consumer choice that will happen later and at the level of the consumer, not at the level of the developer. In order to understand any investment, we have to look at this formula, which I'll explain in detail in a second here. But the general notion is that the value of any investment must be substantially greater than the risk modified cost. If I can take and pay $10 plus a 50% chance of failure, I'm estimating, $20 in perceived cost. If my value is $1,000, this is a really good investment, and I'm going to start investing because the value greatly exceeds my risk adjusted cost. And any investment proposition must make this general proposal true. You must have the value greatly exceed cost. And so far, Space Elevator has focused on two aspects in particular, the capital cost of construction and the technical risks. But we're not focusing enough on the other 5 elements here of risk, financing, and value. And part of what we want to do today is to open up the discussion to include all these other aspects and figure out which are the ones that are most important to focus our energies on in order to make this investment proposition appear as attractive as possible as soon as possible, because we all want to construct a space elevator sooner rather than later. And so we're going to start here by talking about valuation. And this chart, which is on ISEC, is very illustrative of the architecture that we want to build. And one of the aspects we really wanted to draw out that is this distinguishing feature between rockets and space elevators that is completely price independent is this notion of a breakpoint.
Can you bring me?
Sorry, what? Oh, anyway, the notion of a rocket is that per rocket equation, it's an exponential increase. You're essentially building a pyramid of fuel underneath whatever mass you want to bring up. And as you increase your delta V requirements, the same effect happens. And no matter how cheap your rockets are, this is going to be true. Reusable rockets don't affect the physics of the rocket equation. It's an exponential thing where if you want more mass, you need a pyramid of more fuel underneath it. And that increases your cost exponentially. A space elevator, on the other hand, once constructed, has a linear relationship to getting mass into orbit, that you need more time and a marginal amount of energy provided electrically, but that it is mass independent for its ability to deliver high delta V to objects on the end at the apex anchor and fling things anywhere in the solar system. And as a result, this breakpoint will be reached. And the farther we move to the right, meaning more mass, more delta V, something like a Mars colony, space solar power, any number of the mega projects that want to happen, we get closer and closer to this breakpoint. And once you cover the equity shortfall to make up the difference between the CapEx, the capital expense to build a rocket versus the capital expense to build a space elevator, you'll cause this sort of crossover, and then you'll just live in a world of profit and unique value to a space elevator completely independent of the price of either option, just simply because you're moving further and further, more and more tonnage, which rockets just won't be able to do as efficiently. And this notion of having the apex anchor as the sort of terminal to everywhere in the solar system is a very strong, unique value to the space elevator, which makes it incredibly lucrative and powerful for humanity doing these large projects in space, and is really a keystone in making that change take place. But the entire space elevator is valuable, not just this ability to fling things into space. As we've discussed, the GEO region will take and have a very large harbor that can take and support, function almost like a marina for like a naval marina, where ships can dock, they can be constructed. You can have a modicum of safety around this area because you have emergency response, and you're developing the enterprise region all throughout the area around the GEO hub because you're able to move huge amounts of mass into a stable physical location. And this is just cannot be underestimated on how dynamic creating an economy in space is compared to what we're doing currently of creating a system of satellites, which is taking and really working for the service of Earth. As of yet, we have not developed a in-space for space economy. And this GEO harbor would go a long way in the creation of that ecosystem. Additionally, space elevator provides very unique benefits of being able to study things in between the surface of the Earth and the GEO region, where you're able to have effective lower gravity environments like the Moon Gate or the Mars Gate we're showing on a previous slide. And being able to do this kind of testing is very valuable, plus upper atmosphere. And lastly, there's huge implications of what can be built even just above the Kármán line, where Bezos and Branson did their little hop above the Kármán line. You could take and have a hotel here that's 100 kilometers up, get on an elevator for 40 minutes, and you could stay there for a week. You could do anything, and you could look down at the planet, and the safety would be about the same as what you would have on a commercial airline because you're not at orbital velocity. All you would have to do is fall, and you could just glide safely into any airport down on the surface. And this opens up huge opportunities just to have stuff only 100 kilometers up of the 100,000 kilometers we have available on the space elevator. So in sort of sum there, space elevator is valuable because it creates an ecosystem. It's much more of a terrace on which everything else can grow around and through the space elevator and benefit the region, much like the Transcontinental Railroad did in the United States. It's not about the railroad. It's about all the little cities, the mines, the production facilities, the connections that are enabled by the railroad that made it so successful. And one of the other unique values we wanted to express here is that there's a lot of noise on this particular chart, but the amount of rockets that have been launched in the last decade, SpaceX is unique among this whole cluster in that it is increasing more or less exponentially on its number of launches per year. But even so, 2020, we had 42 rocket launches. I am a strong Elon Musk fanboy, but his notion of having 1,000 rockets launching 3 times a day is a pretty big difference from 42 a year. And the real world application of how many rockets can be effectively launched remains to be seen. And we believe that there exists a unique value that while the economics of rockets would indicate that they are going to just continue this exponential increase forever, that's not really how things work in the real world. And that logistics curves are the way true growth happens. And there will be an effective launch ceiling, whether that's a legal ceiling, environmental ceiling, remains to be seen. But there is some effective ceiling here, which will cause this exponential growth to be blunted and to level off, where a space elevator, because of its permanent infrastructure and its ability to increase its mass throughput as needed, will have a much, much higher potential throughput, which creates a unique value at any price because it's able to move mass where rockets cannot practically do so. And this is becoming even more important, and we have observed, even with the few launches that we've had, with more space debris and more mega constellations and things in orbit, having an overlap of launch windows, these purple bars represent human rated safety rating requirements, that 75% of launch windows to low Earth orbit are already obscured because of its possible intersection with the debris we can see. And this problem is relatively minor, and it's definitely something we can currently avoid. But as our skies get more and more crowded, this launch window interference is casting doubts on our ability to effectively launch thousands and thousands of rockets a year without running into severe launch window limitations at some point, which a space elevator can easily cut through comparatively. And lastly, I just wanted to express that, in this architecture being the green road to space, space solar power, which deserves a presentation all its own, I just want to briefly mention, is one of these keystone activities that is extremely high mass and has great economic opportunity. I'm not going to go into the detail of these charts, but electric prices are rising faster than the average price, and the levelized cost of energy for space solar power is making it an incredibly lucrative investment that needs this kind of high mass throughput only a space elevator can provide. And with that, I will hand off to Eduardo to continue our presentation.
Okay. Well, everybody, I hope that you can hear me well. Okay. Well, basically, Kevin has been talking about the value on the left side. I'm going to cover briefly the right side of the equation. We just want to also mention that this equation is simplified, but basically it would need to be detailed much more. But I think in this level of detail is important for the change of paradigm that we are talking today about. The capital cost will be something that we're not going to cover in detail in the next ones, but I would like to mention it in this one. It's something that in the study that has been done for the last decades, it's something in the range of between 10 billion and 100 billion, or Yassi believes it could be up to 100 billion, but it's only, let's say, one order of magnitude of difference, which is important, but it's not as important as the risk associated here. I'm going to talk first about the risk. So the risk, this risk is something that if they go basically to zero, it means that the project will come with an infinite amount of cost, and therefore, from a financial perspective, it would not be possible to cover it. And there are four mainly type of risk, and I would like to bring some examples here on infrastructure of real infrastructure examples where it has been basically an issue. From a political and legal risk, basically this type of project would require an approval probably on the level of the United Nations. So basically, you require a lot of political power in order to make these kind of projects happen. I would like to mention that basically from an infrastructure perspective, normally, like, I don't know, if you want to build a new highway or a bridge, normally the technical risk and the market risk are more or less mitigated, and they would be more or less close to 100% sure that there is not a technical risk, and therefore it will not be. And normally they focus much more into the social and the political and legal risk. So basically making a little bit of political pressure in order to make that happen, and being sure that there is no social risk associated with that. Yeah? While in the case of the space elevator, we need to consider the four of them. I was talking briefly about the political and legal risk. When we talk about the social risk, so you get an idea of what could be. This is Germany. In Germany, there has been a lot of social pressure in order to close the nuclear power plants, and there has been the political decision to close them some years ago. And basically, this is having an impact on increasing the carbon and oil power plants that they have as a way, because they were not ready to, let's say, take them out. But still, despite of from a scientific and from a political or even environmental perspective, it wasn't a good decision. The social risks made it happen that way, and that's why these risks are so important and they need to be worked on upfront. The market risk.
And one other piece, just to kind of add, to harken back to the video we had at the beginning here. One of our concerns on the social risks is this transition between technical assurance that and things are safe, and social fear of what could be, what isn't understood, what would happen when you have this giant tower, which people might imagine falling down, and being able to bridge this gap between the ground truth of what is actually occurring and getting widespread social acceptance of something so new and innovative.
And market risk, I hope that this concept is quite important. This concept here is market risk is how much is the market existing already for this infrastructure, right? So let's say you want to build a road between two cities that they are already having a quite interconnection, a quite important interconnection, then the market is ready for it, yeah? But if you are trying to bring, I don't know, like this bridge out of nowhere, a bridge to nowhere, that is, well, it's a real bridge that is somewhere in the US. Basically what happened here is that you do not have the second part of the market. You still need to develop that market. Yeah, it will be the same as it happened, I don't know, at the beginning with the internet. Yeah, there was a need to connect people, but there was still not kind of the consumers and the producers of content in order to, and this requires a certain amount of time. And again, this is quite important for a infrastructure perspective as well. Yeah, if we take, for instance, I don't know, the solar power, for instance, there is already a electricity grid and electricity needs in the world. So therefore the market is already there. In the case of a space elevator, it has to open up a little bit together with, it has to develop together with the rest of the space economy. So this is a little bit of higher risk, but it's not, it's not impossible. We just need to kind of work together with the market in order to be sure that this risk is manageable. And then technical risk is the part where I think Space Elevator has been working heavily for the last decade, especially with the 2D materials. And again, if any of these risks are coming to zero, basically it's a no-go. Let's say the United Nations say, no, this is impossible, then the whole project becomes infinite costly because the equation on the previous slide. And basically, yeah, there will be, from a financial perspective, there is no chance to make that happen. So this is important. And then in the next slide, Kevin. And this is a good example. This is coming from the infrastructure systems that the UK has. I just want to highlight the canals in blue color there. The canals, they were means of transportation that was happening during the 1700s. However, the technology for making the canals, it was ready before, I think, before 10, I don't know, 100 years before Christ. So basically, despite of the technology being ready, the rest of the other variables, they need to also be ready for it, and that's why we believe that it's quite important to start working on all of them in parallel. And that's the paradigm change that we want to say. Despite of being the technology the most important one, the rest they need to also be catching up and take that attention too. Then okay, we cover capital costs, we cover the risk, and then the last one would be the financing. So, Kevin, you want to comment something? Oh, yeah. Okay, so from the financial pathway, so basically the final frontier is the funding. We believe that the financial pathway, so basically demonstration, seed, funding, then working with initial revenues to have specific revenue streams much earlier than having a full space elevator, then working with a debt once that basically the risk has been decreased, and then working with all that together with a risk-reward analysis that could make the project investable. We believe that is much more common. It's definitely much more common in infrastructure projects. Infrastructure projects try to be low risk, and this is the way. However, there is of course the possibility to get, a Han Solo that says, you know what, I don't care about the risk, I'm just going to go for it. But even in those cases, the plan still needs to be plausible. Means that the risk that is at the bottom of this equation, it doesn't have to be zero in a way that the whole cost is infinite. They have to be a chance that this could be overcome, and the whole plan needs to be in place for this person to believe in the plan and to move this forward. And we want to also highlight here that there is a chance for this kind of projects. And if you take the mega project that has been installed in the last 10 years, many of them has been in Dubai, and the reason for that is because there are more wealthy individuals that they are willing to put more money, and if it's needed, just to increase even the money, compared with a bank that is much more risk responsive to that. Yeah. So in a way, we believe that being the first one, having the name there for being the billionaire that has been making the space elevator is definitely something that goes on top of the financial incentives, and this can make it happen. But still, we believe that it has to have a plausible plan in all the areas of the formula that we were commenting.
Yeah, and sort of just in conclusion of our presentation here today, we just really want to express that Bradley Edwards did a phenomenal job of really taking and convincing much of this community of the plausibility and viability of trying to construct a space elevator and what that might look like. And the work that we've been doing here has helped to move that idea even further along than where he brought it to. And the piece we want to change today is, at the end of the day, we don't care how much it costs. We care how much it makes. And if we're going to get investors that are going to help us to build this and to do all the critical engineering and research work between where we are now and when we have one of these built, we need to really embrace, what does this thing make? And understanding this formula is critical to persuading investors that this is a viable investment proposal, and that as an infrastructure project, we're not a business. Our goal is to have the lowest user price, which will give us the highest utilization and the most value, which increases this green quandary. The more that we can refine and demonstrate this number with things like space solar power or orbit fabs putting fuel depots in space or asteroid mining, anything and everything that we can do to refine and demonstrate value in space increases the mass drive and demand that pushes us further to that right side of the equation where space elevator dominates. And the right side of the equation, on the other hand,
on the price could be even zero. And there are examples, for instance, I don't know, emails and so things like that. They are zero for the users. Yeah, and this doesn't mean that the cost is zero, but it is possible just to subsidize the price, the cost of the structure.
Absolutely. And so we don't want to compete, are not even interested in competing on cost. We should be able to build a space elevator with a price that is negligible to zero, even if the cost isn't. What we care about is how valuable it is to a would-be investor. And that means we have to understand what the capital cost is be. $10 to $100 billion is good enough. That's a reasonable infrastructure project. If that can be executed, that doesn't really need to change. If it's somewhere in that range, it's entirely reasonable. Finance will likely be as much, if not more, than this capital cost. And it proves true that on most infrastructure and mega projects that have happened in recent decades, whether it's the Channel or large dams, financing is a much bigger, complicated hurdle than just coming up with the capital cost. And it is entirely attenuated by the bottom side here, which we've dramatically simplified into a total failure risk scenario. And that if you take and have 50-50 odds on all of these, you've increased the cost effectively 16 times. So if you can go and you can decrease the perceived risk on any one of these, it has a much, much larger lever on affecting this value proposition than a reduction in cost will ever have. And that's the point that we really want to close with. And if anybody has any questions, we'd be happy to field them. Eduardo and I are now Lightbridge Strategic Consulting as well. Thank you.
Thanks so much, Eduardo and Kevin. Thank you for giving us that economic view on what we can expect, and that analysis was great. Thanks so much.